Hello and welcome. It's Thursday, the 11th of December, and I'm currently sitting in Microsoft's head offices here in Reading, looking out over a rather miserable grey day. So for the next 30 minutes or so, I'm going to try and inject a little bit of colour and excitement using the topic of SignalR and the real-time web. If nothing else, at least my slides are colourful. It's been a really busy week for us at Microsoft Developer Experience. That's the team that I work in, and Martin Kern, my partner in crime, which has been helping us with these webinars this week, because we've been delivering one of these webinars every lunchtime on a completely different topic. There tries to be some consistency. It's all about the web, but they are quite disparate topics. So thanks for those that have stayed with us all through the week, and we'd be delighted if you'd also join us tomorrow to hear the irrepressible Martin Kern talk about running and maintaining sites in the real world. If you want to register for that, it's aka.ms/Azure Websites Training. If you like the kind of content that we've been producing, these webinars, and you like the format, then do let us know. You can tweet me or send us an email. I'm the Beebs on Twitter. Also, there is Martin Kern on Twitter. And my email address is martin.beebe@microsoft.com. We'll use any of these quotes to convince our boss that we should be doing more of these webinars. So please help us out, spread the word, be positive about what we're doing. Of course, if you don't like these webinars and you think that it's terrible that what we're doing and the content's rubbish, then also let us know. But if you could perhaps do that on my email address, martin.beebe@microsoft.com, rather than Twitter, that would be much appreciated. So today I'm going to be talking about the real-time web. We're going to first explain what it is and why it's so important. Then we're going to cover ASP.NET SignalR, which is an open source framework built by the team at Microsoft. It was actually built as a sort of side project by Damien Edwards and David Fowler in their spare time, and it was adopted by Microsoft. So it's a completely open source project. It started open source, and you can contribute to this thing if you wish, but then it's been adopted by Microsoft and made part of the ASP.NET family. And it enables real-time web experiences. So we're going to be looking at that, and then finally we're going to look at a few examples and dig into some code. So let's say we are new to real-time, which many of us are, and we're trying to create something like a real-time experience. So your boss has asked you to put a real-time element inside of your website. Perhaps it's a stock ticker, where the stock data is going to update on the server, and our browser, we don't want to do a full page refresh, but we just want that stock price to refresh. Now, the simplest way, if you know anything about HTTP, if you've been a web developer for any period of time, you'll know that the web is stateless. So we make requests to servers, and servers respond with a response, and that's a packet of data. And if we want any more data, we have to go and ask the server. Or that's traditionally how a web developer's thought about the web. It's stateless. But what we're trying to do with real-time is create a communication so that the server, when it has new information for us, can let us know without us making that first request, if that makes sense. So without real-time, we would do something like this. We would probably just kind of make tons and tons and tons of requests with the web server, and the web server would just throw away these requests and say, I haven't actually got any new information about the stock price updating. And then one time we make a request, maybe the fifth time, it will say, oh, actually, no, I do have some data. Here you go. Here's some data. Here's that stock price that you asked for. And then once we've got that stock price, well, we need to keep the stock price up to date. So we're going to have to then ask again and again and again and again, do you have some data? Do you have some data? And the web server's only, maybe in 15 minutes it's got a new stock price, or maybe in 10 seconds it's got a new stock price. But we're having to make all of these requests just so that the server could choose when it wants to respond to us. The server knows that it hasn't got any new data. So what you can see in this pattern is there's a ton of inefficiency. Only that pink line is really valuable data. All of the rest is just requests, overhead, network traffic, which is really unnecessary in the whole kind of architecture. So what happens when we look with something like SignalR? Well, the client browser might support various ways of doing real-time. If it supports something like WebSockets, that's ideal, and we'll come to that a little bit later, showing about the different fallbacks and different methods for this. But let's say the client browser does support WebSockets, and it says, yes, I do real-time. Do you support WebSockets, Mr. Server? Because both ends really have to, when we're doing real-time with WebSockets or server-side events kinds of thing, both sides of this equation really need to support real time. So we'd say, well, do you do real time web server? The web server says, yes, I do real time. And then they just start partying in real time. They can kind of work together and do stuff in real time. And there's a duplex connection between client and server, where not only the client can make requests and speak to the server can independently speak back to the client. So this is effectively real-time information. So when that stock price updates, the web server can just pass information back down to the client browser. So basically, SignalR negotiates this kind of the complexity of all of this, because there's lots of different methods that we could connect client browser and web server with. But SignalR kind of simplifies all of that and just makes this effectively a pipe that we can pass messages back and forth from the client browser and the web server. So we can quite easily implement that scenario of a stock price being updated, but without all the overhead of the client browser making tons and tons and tons of requests, specifically if they're using modern browsers. So let's look at SignalR and explain how SignalR, we'll look at SignalR and see how it works in modern browsers, but also how it works when we're looking at older browsers as well, because SignalR does support the whole array of browsers, pretty much everything down to IE7. So SignalR doesn't just work in modern browsers, it works everywhere. It works better in modern browsers, of course, but it works pretty much everywhere. So SignalR makes it pretty straightforward to build real-time applications. When we use SignalR, we're able to have a duplex communication between the client and the server, and SignalR is kind of handling all of the complexity of managing the connections. It gives us an API that allows us to pass messages to all of our connected clients. Or if we use hubs, then pretty much in all instances you'll want to be using hubs, and that's a concept we'll come to later. We can wire up functions in JavaScript to functions on the server, or have the server execute JavaScript functions on the client, which is pretty weird, mind-blowing, and neat. A server can broadcast messages to all the clients that are currently connected to that server, or it can execute functions on one specific connected client. It's a very strange concept for a web developer to get their head around, but SignalR does enable persistent connections over HTTP between client and the server. And what's more, SignalR will work on really old browsers, IE7, and it doesn't require any kinds of plugins of any sort. This is all in-browser technology. It's using standards or various web technologies which are built into browsers. And the actual implementation of SignalR on the client side is all done in JavaScript. Now, different browsers have different capabilities, of course, and SignalR will auto-negotiate the best transport to use based upon the capabilities of the server and the connected client. SignalR is able to support older browsers because it supports 4 different ways of achieving real-time, or the effect of real-time. Currently, the best method is WebSockets. And so if a user is on a modern browser and is connected to a modern server that supports WebSockets, then SignalR will choose WebSockets. Now, I say currently WebSockets because there's no saying that something, and there's a good chance actually that something else will come along which will be better than WebSockets. And this is one of the benefits of using a framework like SignalR. SignalR is abstracting all of these 4 different ways of doing things, or of doing real time. And if there's a 5th way, SignalR can add that in, and you're still programming against the SignalR API. You're not programming against, whatever new fancy real time standard comes out in browsers. So in some ways, using an abstraction like SignalR helps with future-proofing your code, because should another way of doing this real-time web come out, it will just be a patch to SignalR, or adding a capability to SignalR to start using that rather than, say, WebSockets. So it's really cool for future-proofing, but it's also very cool for making sure it supports older browsers and older clients. So if WebSockets aren't available in a browser, it will try server-sent events, and then if they're not possible, it's going to use a method called forever frames, and finally long polling. Long polling obviously being the least efficient method of doing real time, but it will work all the way back to browsers such as IE7. Long polling, if you're not familiar with that term, is you basically make a request to the server, and then the server holds that request open so that it can pass stuff back. So it's like time, like it doesn't time out. Basically, it's a request that doesn't time out. It's intended to be left open, but that's inefficient because obviously you've got all of these open connections on the server and these requests which are potentially blocking on the server. So it's a long pole is not the best way of doing some of these things, but something like WebSockets is a much more lightweight socket which is intended for this kind of purpose. So the more modern the browser, the more modern the server you're running on this, the better and more performant SignalR is going to be. Now, it's important to remember that SignalR can scale to thousands of connections, and particularly if you're using like with the WebSocket stuff, then that's a very light socket connection. So you can have thousands of connected clients to one particular server. You can scale this thing. You can scale and manage multiple servers using a backplane like Service Bus, where you pass messages between servers as well as clients. And it's important to remember this is all open source on GitHub. So it originally started out as a side project on GitHub, and it's kind of made its way into the .NET framework. But it's still all open source. You can look at all of the code, how it's implemented. You can look at all the server logic and how we implement the server logic. I say we. It's certainly not me which is doing it. But you can see how the guys are implementing all of the various logic, all the logic required. And of course, with it being open source, if there's something which you didn't like about SignalR, or a new technology came along which it didn't support or wasn't planning on supporting, but you wanted to support in your organization, then of course you could modify this code, use it as a starting point for your own system. But if you don't want to do any of that, of course, that's completely up to you. We package it up, we make it available inside of Visual Studio, and you'll see when I come to write a demo, it's all very nicely integrated into Visual Studio. You don't have to go and compile any of this stuff from source or any of that, but you can if you want to, which is a nicety, a nice thing to have. So to scale, SignalR will need a backplane, because obviously if you're running, and the example I'm going to create today is just a number of connections, probably under 1,000, which are connecting to a single server, and that's fine. But in a multi-server or multi-instance environment, communication sent from the client will only ever land on the server from which the originating call was made. If other users are actively connected to the application but on different servers, the real-time communication won't cross those servers. If your application needs to run in a multi-instance sort of manner, a backplane is going to be necessary to maintain synchronization between those servers. Now, so we have this clients connecting up to those to the load balancer, then it's connecting onto the servers, and you'll see they just don't have any. There's no communication happening between those servers. The communication, whatever messages are getting passed, are only getting passed to client and to server. Now that we've added a backplane to this architecture, the server or those little nodes can transmit data between each other via this server, which is cool. I don't know if you can see this on the slide. It's got some nice PowerPoint animations there of messages getting passed between the servers and the various clients and so forth. So a backplane is really a mechanism to keep all of the servers synchronized, and you could use something like Azure Service Bus to handle this, the messaging, passing the messages. Service Bus being a way of passing messages very efficiently on the Azure platform. But you could use anything really as your backplane. So now we're going to move over into a little demo of what SignalR is and try and build a little application. So I'm just going to go into a version of Internet Explorer and click on shooter.signalr.net. And this is a little game which was built by the guys, by David Fowler, Damien Edwards, and it tells you a few other people there as well. So the people which kind of originated SignalR. It's a demonstration of a multiplayer online game which is using SignalR to kind of create a space shooter game, which I'm not particularly good at. And if you join this game, even now, you could play against me and kill me or whatever. But what's cool about it is that this is all happening in real time. The spaceships are moving, messages getting passed about other people's positions, and we're able to shoot each other up in real time, which is nice. Okay, so now we're in Visual Studio. I'm going to click on File, New Project. I'm just going to choose a website, Web Application 24. I won't worry about source control at the moment, and we'll build that thing. I'm just going to create an empty website and click on OK. So to this empty application, I'm going to right click, I'm going to add a SignalR hub class. I'm going to call this Chat Hub. And that's going to do some bits and pieces. It's going to download some code and set up my project. If we look inside of the scripts folder now, it's added jQuery because jQuery is required by SignalR. We've got a jQuery SignalR kind of the plugin, which is basically the JavaScript framework, the SignalR JavaScript framework. We've got a minimized version and a regular version of that. And it's added this chathub.cs file here as well. Let's go in here, and I'm going to use a little snippet, which adds a new chat hub to my application. A new class called Chat Hub to my application. I currently have a static tuple. I love the word tuple. A list of tuple, actually. It's just a way of storing some messages. And this is going to store a username, a string for username, and a message that someone will, be broadcasting in the chat room, because that's what we're trying to build here, a little chat room. When the class is initialized, when Chat Hub is initialized, if the message tuple is null, it's just going to create a brand new one, a brand new list. And this contains two methods. The first one's called login, and this is sort of quite interesting because clients are all of the connected clients to that hub. So it's basically saying, well, clients dot caller. So whoever called this function, now you might think that's quite strange because whoever called this function, well, you would expect that usually to happen from C#, but of course this is going to be executed by JavaScript. So SignalR sets up with these hubs, it sets up a proxy. And what's going to happen in our JavaScript code, in our page, we are going to be calling this logon function on the server. And then this logon function is going to say, well, whoever's calling me, that one client that is calling me, which is connected to me, I'm going to load the history. I'm going to basically take all of the messages which are in this tuple, and I'm going to print them out to them. This list of tuple will get serialized using JSON Newtonsoft into a JSON package, which will be sent back down the wire to the function, the JavaScript function on that specific user's machine called load history. So the client is connecting to the server, and then the server is actually physically passing or executing JavaScript on the client, which is pretty mind-blowing. And then we've got one other event called send. And again, this is going to be something which the client is going to execute in JavaScript, and they're going to call a function called send and pass over the name of the message, which is the username of the chat user and the message that they want to send. And then we're going to be using, we're going to firstly just put that into the tuple. So we're going to have a way of storing this information. Now, in a real world, we would store this in a database, or we'd maybe store it in a backplane, or we'd store it. We'd put this somewhere which is persistent, but for the purposes of this kind of cheap demo, it's easy just to store it in a temporary store like this in memory. And then we're going to use another method on the client's property called all. So all of the clients, rather than the clients.caller, we're going to call all of the clients. And on everybody which is connected, call the JavaScript function broadcast message and pass the name and the message. So every time someone sends a message, that message will get stored and then relayed back to all the connected clients. And that's pretty amazing. You know, the server has got some new information, and it's going to be able to then execute some JavaScript on those clients and pass that new information to every one of those people. Whether or not they're not having to make requests to the server, because we've got this channel open, this communication channel, we can just do that in real time, which is really cool. So next up, I'm going to have to add something to host this on. So I'm going to use I'm going to add an Owen startup class. Let's call it start up. And just down here, I'm just going to say app.map SignalR maps the specified SignalR Microsoft.ASP.SignalR persistent connection to the app builder pipeline at the specified path. It wires all the stuff. Okay. And now I've set up this Owen compatible kind of the thing which is going to be able to map this or host this thing. I'm going to next I'm going to just try and connect or create some UI so that we can actually send some messages, so clients can actually send messages to the server. So we've implemented the server side stuff. Now we need to implement the client side stuff. So I'm just going to add a very simple HTML page, index.html. December chat, webcamp 11th December chat, and right here I need to just add some JavaScript. And what this is doing is it's basically setting up my my connection to the chat hub. So SignalR is added to this page at the bottom, somewhere here. We've got references to the SignalR library and the jQuery library that we're needing. We've also got a reference to Bootstrap that we don't currently have, so we're going to have to download that via NuGet. We've got a connection to the chat hub, and here's that method, that chat.client.loadHistory function. So this is the function which is going to be called whenever someone logs on. So when the user logs on, the load history method is going to be called, and that will execute this piece of JavaScript. So it's going to just log some stuff to the console, and then I'm going to use some jQuery just to loop through all of the JSON files that get responded and just paste that into, or just build up a table of those messages. You'll see that here's where the connection hub starts. So connection.hub.start.done, and then we call that chat.server.login. So from JavaScript, we're calling the logon function, and then from the server, we're calling the load history function. Getting confused with my files. So logon, the server then calls load history, and we then attach a click event to the send message button, which basically says, it does a bit of logic, but ultimately what it'll do is say chat.server.send, and we pass over the username and the message, and then that gets sent over to send. That would then be sent up here to send, and then once it's received by the server and saved into the tuple, it's then going to call clients.all broadcast messages. So then on every connected client, it will execute this piece of JavaScript called broadcast message, which is here, chat.client.broadcast message, and it's going to receive the name and the message as parameters. We can see that the name and message are passed by C#. It's going to be received in JavaScript here, the name and the message. We're going to take that information, and again, we're just going to add it and prepend it to the table of messages. So you'll see the way that SignalR kind of works when using these hubs is that you send messages from JavaScript, and you send those over to a server, and then the server can actually then call back into JavaScript, which is really, really interesting and cool and weird and magical. Now, the only other thing to look at is just my bit of code, which represents the UI. If you joined us on Tuesday, I did a session on modern front ends where I talked about Bootstrap. If you've never seen Bootstrap, then a lot of this notation, like container and the col leg 12 thing, this is Bootstrap. So take a look at Tuesday's session. It should be online now. And we use this to create a responsive website. I actually don't have Bootstrap added to my project, so I'm just going to add it via NuGet. Okay, so then I can go to install Bootstrap. It adds the required Bootstrap files, Bootstrap.js, JS, and then there should be in the contents of Bootstrap the theme and the CSS. And then when I run this thing up, so now I have the webcamp 11th attempt chat on my machine. I can say the beebs, spell it wrong, submit something. I'll spell the beebs right. And you can see that it's getting passed correctly to the different to the message window. And as we can see here, we are I've just made this smaller, and so the site has responded correctly. And we're using Bootstrap here to manage the responsiveness of the website. So it's just put the messages underneath the message window. So now if I take Chrome and put it alongside it, and we do, oh, can we see this? Put it alongside it like this, and put Chrome. What we should see is the message pop up at the bottom corner of the screen when we click submit. Oh, top side of the screen, sorry, when we click submit. And then I can say hi from IE. And you see almost instantaneously these messages are getting passed between the browsers via the server, very, very quickly. Things refresh as you'd expect. And also the same is true of Firefox, so we can say Firefox, hiya, and that goes across all three things, and even slightly less used but wonderful browser called Opera. We submit there, and it passes through to all of the browsers that you would expect it to. So this is real-time communications. It will work across any browser, and the rubbishy thing about this demo at the moment, though, is that it's just on my local machine. So let's fix that. Let's put it somewhere which is not local, make it more interesting, because there's no point doing real-time with yourself. So I'm going to go up to Web Application 24. I'm going to go Publish. Publish to Microsoft Azure website. Create a new one. We'll enter a website, which will be Webinar 11, which is available. Put it on pay-as-you-go. We'll stick it into North Europe. North Europe is Dublin, which is odd because West Europe is Amsterdam, but never mind. Create that thing. And it's going to whir away. It's going to create me a site. It's going to download some publish options, and then I can just publish this website directly up to Azure. Okay, and it's live on the So next I'm going to just go to Internet Explorer F12 tools. Now, this is interesting. You might be thinking, those F12 tools look different, Martin. That's because last Tuesday, or on Patch Tuesday, these were updated. So we took feedback about the UI of the F12 tools in IE, and now we have this beautiful kind of top navigation, as almost every other Dev tools has. I don't know. I think it works better because it used to be these icons which are very difficult to distinguish between. But now we can go to the network tab, and we can see on this live site that it's using a forever frame. It's not using WebSockets. So why would that be? Well, the problem is we're doing all the right things on the client side, but when you initialize an Azure website, it doesn't have WebSockets switched on. So let's go and switch that thing on. So over on the Azure dashboard, I've got the website webinar 11. And if I click onto that and I go into configure, I scroll down and I find WebSockets. I can switch that on. Can save that thing. And now hopefully we should have WebSockets switched on now. So now this site now is running using WebSockets.